Simplifying radicals is actually very similar to the way that we simplify fractions. In both cases, we can think about the prime factorization of a number. Basically, what are its most simple components? Start by thinking of any factors of the number under the radical. For me, the first thing that comes to mind for 80 is 10 times 8. Then I can start branching off those numbers until the end of every branch is a prime number. This tree shows that the prime factorization of 80 is 2 times 2 times 2 times 2 times 5. Next, we want to make groups of factors based on the type of root. If it's a square root, we need pairs of matching factors. In this case, I can make two groups of 2. Each pair turns into a single 2 that gets placed outside of the radical. The 5 doesn't have anything to pair with, so it stays behind inside the radical. Now just simplify by multiplying the numbers on the inside and outside of the radical, so the square root of 80 simplifies to 4 times the square root of 5, or 4 radical 5. Eventually you'll need to simplify more complicated radicals, including cube roots and higher. As long as all the terms inside the radical are being multiplied, we can use the same basic procedure that we used in the first example. Things get much harder when the stuff under the radical includes addition or subtraction, but that won't happen very often. Let's try this example for 2 times the cubed root of 72x to the 4th. First, I break 72 up into its prime factors. I know that 72 is 9 times 8. 9 is 3 times 3, and 8 is 4 times 2, and then the 4 is 2 times 2. If you had broken 72 up in a different way, you'd still get these same prime factors at the end. That's the best part of this method. No matter what you do first, you'll end up in the same place. So just follow your instincts when you're breaking up the number and don't worry about being efficient. This time, I need to make groups of 3 since I'm taking the cubed root of 72. The number in the root tells me how many factors need to be in each group. So a 4th root needs groups of 4, and a 10th root needs groups of 10. In this case, there are 3 2's, so a single 2 will come out of the radical. But there are only 2 3's, and we need 3 to make a grouping, so those 3's will stay behind inside the radical. The 2 that's already outside the radical doesn't affect anything on the inside. Just leave it where it is. We'll deal with it later. We can also do this prime factorization with the x to the 4th. We need to remember what exponents actually mean. Basically, x to the 4th means that we are multiplying 4 x's together. If I write them all out on branches, I can see that I have a group of 3 x's, which come out of the radical as a single x, just like the group of 2's did. But there's also one left over x, which will stay behind just like the 2 3's. Finish up by multiplying all the outsides and insides together, and we get 4x times the cubed root of 9x. Remember to like this video if it helped, comment if you have a question, and subscribe to this channel so that you never miss a new video. Thanks for watching.